All right, let's try to finish up with what we started yesterday. And we're going to do a little bit of graphing, just one graph. But here's what we're going to do. Do you remember I didn't write it right here, but do you remember what the quadratic function is? Do you remember what all those letters? Remember all these different letters? Off the top of your head, you remember? A, and then parentheses, x minus h, and then squared, and then plus k. All right, there's a couple things you know about this. Remember this is just review real quick. This is plus or minus. Okay, the plus means what does the parabola do? It's a quadratic, so it's a parabola. So what's it do? It opens up. If it was negative, it opens down. The A tells you how wide it is, or what's the other one? Well, how steep it is, and what was the other one? Flatter. We use flatter, okay. Or same thing, wider, flatter. All right, so that tells you that. I think we talked about this, didn't we? What is the vertex? Do you remember what the vertex is? HK, very good. All right, we're going to learn something else. When it's in this form, we use HK, but it's not always in this form. That's what we're going to do in the first example, okay? But when it's in this form right here, the vertex is HK, all right? And also, we learn the axis of symmetry. Do you remember that? The axis of, I don't think we wrote it down exactly the way I'm going to write it right now, but how do you know the axis of symmetry? Remember, the axis of symmetry is a vertical line. So how do I write a vertical line? X equals, okay, well, it's not always 0. Where do we look for this to find where it crosses the x-axis? Right there, okay? So it's x equals what? H. All right, so whatever that number is, if that was a 3, if it was x minus 3 in parentheses squared, okay, how do you know what the x or the axis of symmetry is? It's where the h is. So you go to 3, right? Isn't that the middle of your vertex? Yeah, and then it's just a vertical line up and down. And it's the same on one side as it is on the other side. Remember that? Okay. So that's all old stuff. And it was good. Everything's good when you have it in this form right here. But quadratics aren't always written in that form. So that's what we're going to do today. So here we go. What if you have, this is an example. I'm going to go right to the example. All right, this is example 4. And here's your function. But it's not written like this. So it's hard to just look at it and pick out which one is the vertex, which one's the axis of symmetry, and all that kind of stuff. By the way, we didn't mention this. What does that k do to our parabola? Moves it up or down, right? And the h also moves it left and right, okay, depending. Everybody with me on that? Yeah. Okie doke. So let's do this. F of x equals x squared plus 3x plus 1. All right? Now that looks a little bit different than what that formula, right? What that formula gave us. Do you agree? So we could do a couple things. We could change it into that formula. What formula am I talking about? This right here, this function, okay? I want a number out in front. I want this to be a perfect square, and I want a constant out to the right. So that's what I'm going to do with this. We're going to use something that we've used before, okay? We're going to use it slightly different, okay? Just slightly differently. Can you say those two things together, I guess? Slightly differently? Is that all right? Okay. That's what I was thinking. Now it's slightly different. That works, doesn't it? Yeah, that's why I had to think about it. All right, here we go. What we're going to do is try to turn it into that. So we need a perfect square. So we're going to do something that we learned earlier, but we always had it set equal to 0. This is not set equal to 0, but we're going to do something. Do you remember the two-way? Well, if you wanted to solve for x, you could complete the square. And that's what we're going to do right here, okay? We're going to complete the square, and we're going to make it look like this thing right here. Everybody with me? All right, so we're going to do a little bit of math to make it look like that. So here we go. I'm just going to keep this f of x equals, I'm going to write this x squared plus 3x. You remember this with completing the square, we put plus what? A blank, correct? Now before, we always had equals 0, didn't we? All right, but we don't have it equals 0, and we're not going to do that. We're just going to keep this right here. You still got that plus 1, so I'm going to put the plus 1 there. All right, so now we got to figure out what's going to go right there. We had a little trick, not a trick, but a little procedure that we did to figure out what goes there. Do you remember how we did that? Yep, we take that middle coefficient, 3, we divide it by 2, and then you square it. What does that give us? 9 over 4. So what we're going to do is we're going to add a 9 over 4. Whoops, thought I changed the color. What? Ugly color. Oh, number. Yeah, it is, but that's okay. 9 over 4. Now, here's the thing that I said was slightly different. When it was equal to 0, remember you add something to one side, then you add it to the other side? But this time, we're not going to add it to the other side because I just want this to be f of x. Okay, but how could I add a 9/4 here and then not change the value of this? Think about it. Yes, you got it. Minus a 9 over 4. Because really, what did we do? We just added a 0, didn't we? All right, 9/4 minus 9/4 is 0. Did we change the value of it? No, but we did make this right here so that we have a perfect square. Does that make sense? Yeah. All right, so keep that in mind. That's important. That's why I put it in a different color, just so it pops out a little bit at you. All right? I'm not going to keep writing f of x every single time, but it is over there, okay? So what do we have here? I made this into a perfect square, so I can do this. So what's going to go inside of here? X plus 3 over 2. Good. So you should be able to do that pretty easy. Either take the square root of that or just take this and divide it by 2. It's the same exact number. All right, then we got to do this. We got to add this. And we could do this in your head. Can you do this in your head? What am I going to change 1 to? 4 over 4. Right. So it's 4 minus 9 over 4. What's that? Negative 5 over 4. Good. All right. Now, check this out. Now this looks like that quadratic function thing that I had earlier, right? So first of all, let's take a look at it and see what's going on. All right, so does this open up or down? Opens up because there's positive right here, okay? What's the shape of it compared to just a normal y equals x squared? It's the same, right? Because there is a in front of it. It's a 1. But it's not greater than 1, it's not less than 1. It's not going to go steeper, it's not going to go flatter. Everybody see that? All right, so we know that. What else can we learn about this thing? The what? The vertex, right? So what's the vertex of this thing? Right, negative 3 over 2 and what? Just negative 5/4, that's right. Okay, so that's our vertex. Yeah, that's kind of what they ask you. They don't even ask you to graph the thing, all right? They just ask you for those. Does it open up or down? Compare the shape, right, to an x squared. We already talked about that. It's got the same shape. It opens up, and that's your vertex right there. So that's a good starting point, all right? What would your axis of symmetry be? Yeah, it'd be x equals, what'd you say, negative 3 over 2. That's right. What does that mean? So let's do a super rough sketch. All right. So where is it? So this is what? Negative 1.5. Is that right? And this is what? Negative 1 1/4. So what do? Go negative 1.5 and go down negative 1 1/4. Yes, like this. And what's it do? Kind of goes like this and kind of goes like that. And what is this line right there? That's negative 3 over 2, right? Or negative 1.5. That's your axis of symmetry. Does that make sense? So we know all that stuff just by looking at this. All right? This is super important. And how did we get it to look like this? We completed the square so it looks like that. All right? Make sense? All right, let's do another one. Let's do example 5. Kind of the same thing, but this time we're actually going to graph it. All right? And so let's write down our function. It's a little bit more involved, but the numbers actually come out nice. They don't come out to fractions like the other one did. That's why they didn't ask you to graph that one, probably because of the fractions. Not that you can't graph it when they give you fractions like that or when you come up with fractions, but in examples, they don't usually do that. All right, let's do this. What are we going to do? This, What you're going to do here first, you don't want to really complete the square right now, okay? We usually use completing the square when this thing out here is a 1, all right? So let's make that a 1. So look, I got a -3 here and a 6 here. So what do you think I'm going to do there? Yeah, factor out. Yeah, technically it's dividing by, but we'll say factor out a -3. Now I'm not going to factor out an x. It does have an x in common, right? But I don't want to factor out an x because I want it to be x squared something, all right? So I want the x squared to be there. I'm not going to factor out the x. So I'll just factor out the -3. All right, what do you have left then? What's here? X squared. What's this going to be? Is it plus? It's going to be minus because if I distributed negative times negative, right, I'm taking this and I'm dividing this by -3, which gives me what? -2 and then an x. You with me? I'm just going to close the parentheses for a second. Actually, we could do this. Yeah, let's close the parentheses. We'll do that in the next step. And then you got your +1 right there. This still isn't parentheses with a squared on the outside, is it? So that's what I want to do. I want to make it that. So how are we going to do that? Well, -3. I'm going to go x squared minus 2x. What am I going to do? I'm going to complete the square, right? So I put plus blank. You could put the blank there. You could just leave it blank, however you want to do it. But I always like to put the blank there. And then we'll just push that +1 over there. Everybody see what I'm doing? All right, so now let's do what we did before. How do I complete the square? Well, I take that middle coefficient, and then I do what to it? Divide it by 2 and square it. That gives me -1. What's -1 squared? It's +1. So let's do this a different color again. So I add a 1. Now, you got to be real careful. Hope you're awake on this one, okay? Because this is a little tricky, all right? This may mess you up. On the other one, it was just a 1, we would put -1, correct? But really, is this a -1? Not really, because what's that -3 doing to that 1? It's multiplying, isn't it? Yeah, distributing, you're right. But it's multiplying, -3 times 1. So really, what do we have over here? We got a -3. How do I offset that so I keep the value the same? Exactly. So that's a little bit tricky right there. Everybody see that? We didn't have to do it on the other one because we just had a 1 out in front. But this time it's being multiplied. That 1 is being multiplied by this -3. So -3, okay, you basically just added a -3. Correct? So how do we do the opposite of subtracting a 3 or adding a -3? We add a +3. So really, what did we just do? We just added 0, didn't we? Yeah? This is -3 plus 3 is 0. Is the value of that thing still the same as it was before? Yeah, absolutely. So now what we can do is we can factor this. Can somebody open the door, please? Ah, she's more important than me, huh?
She's leaving. She won't be here tomorrow, so it's like my only time. So I'm being busy now.
That's fine. Can you take it before class? Do you have any time during the day?
Can I take it? Because like all the soccer and because a bunch of people are missing it.
Today, a bunch of people are missing?
Yeah.
All right, we'll just take it with them, I guess. Yeah. All right, so what do we do here? By doing this thing right here, I made it into a perfect square, didn't I? So I can just do this. What do I do here? X minus 1. Do you agree? And then what's this going to be? +4. So now we are ready to graph that thing. Let's talk about it. What's this thing going to do? What's that negative do to it? Opens down. Okay, that 3, what does that do to it? Makes it steeper, right? Makes it thinner, okay? Whatever you want to say. Makes it steeper. What's up with these numbers? This -1 and this 4. What does that tell you? Okay, it does move it to the right, and this moves it up, but that basically just tells us where we're going to start, our vertex. So I think writing down the vertex is super important. So what's our vertex? Is it -1 or 1? It's +1. Okay, remember, this is x minus h. What's our h? Our h is just a 1. Okay, and then our k is a 4. So that's our vertex. It opens down. It is steeper. All right, and there we go. Let me grab some graph right here. Just make it look a little bit neater, and there we go. All right, so here we go. We could take something that looks fairly complicated and actually have a pretty good graph of this thing. All right, so let's do it. Let's do some red. So what's our first place we're going to start? 1, 4, right? There's 1, 1, 2, 3, 4. So there's our vertex. I don't think they ask you, but they could say, is this a minimum or maximum? If the thing's going down, what's the vertex? Vertex A, maximum. Okay, if it was going up, it was opening up, where would the vertex be? It would be at the, no, if it was going up, the vertex would be at the bottom, so that'd be a minimum, okay? They don't ask you that, but they could, all right? So what do we do here? This is going to be our axis of symmetry right down the middle. So let's just try a point right next to it, all right? Remember, let's try a point right next to it. So where would that be? That'd be 2, wouldn't it? So let's plug in a 2 and see where it's going to land. So we are going to have to do that. We're not really drawing a table and just putting random points in there. We're picking specific points. I want to go just 1 over and figure out, what is that minus 3? What is that 3 going to do to my graph? So let's put a number right there. Okay, let's put a 2 in for this. So it's negative 3. 2 minus 1 is 1. 1 squared is 1. Plus 4, what do I get? Negative 3 plus 4 is 1. So if I put a 2 in, how far am I going to go up?
1.
Just 1. Now, I don't have to do that to go the other way because it's symmetrical, isn't it? It's the same on one side as it is on the other. So if I went to the right one, I would go down to here to positive 1. If I go to the left one, guess where I'm going to go? I'm going to go right here as well. Make sense? So there's the beginning of our graph. You can kind of see how it's a little bit steeper than it normally would be. All right? Let's just put one more point in there, just see where that is. So let's put a 1, 2, 3. Let's put a 3 in for this. So it's negative 3. 3 minus 1 is 2. 2 squared is 4 plus 4. What's that? Negative 12 plus 4 gives me negative 8. So when I put a 3 in for this, 1, 2, 3, where do I go? I go all the way down here to negative 8. So really, I only had to put 2 points in, right? And they were points that I could see, and I could figure out where to go. So what do we do here? So I went over 2 this way. So if I go over 2 this way, 1, 2, I would go all the way down to here. And there's your graph, all right? So you can do a nice sketch like that. It's close. Kind of make that nice and curved, and that would look like this. And there you go. There's the sketch of your graph. So you took something that looked kind of crazy, and before today, what would you have had to do? You would have had to put a bunch of points in here, wouldn't you? All right, you're not really sure where to start and all that kind of stuff. All right, but by doing this, by doing a little bit of math and putting into this function form, this quadratic function form, then it's a little bit easier to see. We good? Yeah. All right, let me show you one more thing. Now, we just learned that we should take this, all right, and turn it into that, all right, to find the vertex and the axis of symmetry and all that good stuff, and if it's a maximum or minimum. But there's another way. Okay, we can go directly with this stuff right here and find what the vertex is. Now, I'm not going to do this. I actually just watched, I wasn't even trying. I was watching a video of this guy on YouTube, and he actually went through 3 different ways to come up with this little formula. Maybe I'll, who knows, if we have some downtime, I don't know, maybe even today. We got to what, 5 after? Yeah, we might have time. Maybe I'll show you the video. He shows you 3 different ways to come up with what I'm going to show you right now. So I am not going to show you how they came up with it right now, just because of time, because it does take a little bit of time. But there is a formula to find the vertex. All right. So the vertex, remember, what letters did we use to represent the vertex with that other formula? H and K. All right. So here's a lot of work. All that scribble right there, that's a bunch of work. Okay. I'm not going to do the work for you. I could. It's in the book. It's on the video that I might show you today. All right. But what I'm going to do is just show you what it is. And you're probably thinking, where does that come from? Now remember, we're using these letters right here. Ax squared plus bx plus c. All right? So here's what we do. The h is equal to negative b over 2a. Again, you're like, where'd you get that, Mr. Hamrick? Well, it's in the book. There's videos that show you how to get it. I'm just not showing it to you. I'm just telling it to you. We good with that? All right, what is the k? The k, it's kind of similar to it. It's negative b, but it's squared, and then it's 4a. The negative's not being squared, just the b, all right, over 4a plus c. What's with all these a, b, and c's? Well, that's your a, that's your b, and that's your c. You with me? Okay. So if you wanted to write, instead of writing HK for vertex, what could you write? It's a little hard to remember, but the more you do it, the more you might be able to remember it. So there's your H. What's your K? It's negative b squared over 4a plus c. And you might be looking at this and you're like, well, Mr. Hamrick, to tell you the truth, I would just rather complete the square and then figure out what your H and K is. And you might be right. It might be about the same amount of work, but probably not. It might be a little bit easier this way. So let's do an example, and let's find the vertex. So here's your example. Here's your function. It's f of x equals negative x squared minus 2x plus 1. If you wanted to do it the old way, what would you do? Complete the square, right? Do all that stuff. Look at your h, look at your k, boom, there it is. Or if you didn't want to complete the square, you could just use this and figure out what your h and k are equal to. You okay with that? Does that make any sense? All right. So this is negative b over 2a. So remember, what's your a here? You don't really see it, but let's put it there. It's 1, negative 1. What's your b? Negative 2. What's your c? 1. So I'm just going to plug that stuff in. And for some people, it's a lot easier just plugging it into a little tiny formula like this than going through that whole completing the square thing. All right? It just depends on what you like better. Negative b. So what's my negative b? It's negative 2, which is 2, right? Over 2 times a, or 2 times negative 1. All right? So whatever number that comes out to, that's my h. All right? Comma. This is my k. Let's do that. So it's negative, what? B squared. So the negative 2 is in parentheses squared over 4 times a, what? Plus c. What's my c? It's just a 1. Now, if I just simplify that, that tells me my h and k. I don't know. Do you like that better? Would you rather just plug those numbers in? Okay, probably a little easier. It's just arithmetic, right? You don't really have to do any algebra. It's just substitution. You work it out, and you're good to go. So what's this? This is negative 2. What's 2 over negative 2? Negative 1. So that's your h. Let's do this. This is negative 2 in parentheses squared. That's a 4. That becomes a negative 4. The bottom is negative 4. What's negative 4 over negative 4? It's a 1, and then 1 plus this 1 gives you 2. And that's your vertex. Everybody see that? You could have completed the square if you wanted to, and you still would have come out to the same thing. All right, first of all, is this a maximum or a minimum? Look at your function. What's this graph doing? It's opening what? Okay, it's opening down, right? So that vertex must be a what? A maximum, right? So if it opens down, the vertex is at the top. If it opens up, the vertex is at the bottom, right? So if it opens down, your vertex is negative. I'm sorry, your vertex is a maximum, okay? There's your vertex right there. If they ask you the axis of symmetry, that's pretty easy. What is it? It's just x equals whatever that is right there. X equals -1. So that's your axis of symmetry. And if you wanted to graph it, you could now graph it. Just plug some numbers into this, right? I mean, to start it off, it'd be easy. Where do you start? -1, 2. There's -1, 2. It opens down. So what do? You pick a number over here, plug it in, pick a number here, plug it in. What's it going to look like? It's going to look something like that. Yeah. So now look how easy it is to graph this kind of stuff. So in my last class, we were talking about algebra and that kind of thing. And they said, oh, slopes. I hated that. I hated graphing y equals mx plus b. Like, well, wait till algebra 2. All right, you're going to wish you were graphing y equals mx plus b. It was so much easier. So, but this is getting better, though, isn't it? Do you think? All right, you might not have I don't think I have a complete understanding of it, but at least I think we have a much better understanding of it, okay? These give you clues, don't they? These numbers, these signs, all that kind of stuff gives you clues. You got this little formula right here. That's super important, all right, if you're going to use it this way. You could always go to completing the square and still get the same information, couldn't you? This is just slightly easier than doing completing the square. If you wanted to, try it. I'm not going to. I thought about it, but I'm not. It's half a year of sleep anyway. So look around. Knocked them out. All right, so anyway, there you go. That's how you graph something like that. And, I mean, this is not like an exact graph, but you could always put, what would you do? I'd put a 0 in for this and figure out where it's going to hit. Put a -2 in for this, see where it's going to go hit. Put another number in just to the right if you want to be really specific about what the graph's going to look like. All right, so, but this is just a nice little rough sketch. That's what it's going to look like. I can't hear you. How do you take that and do what? How do you take this and put it into the other form? Yeah, you would do it by completing the square. All right, so let's do it. We got time. I'm not going to show you that video anyway. So, so let's just do it and see if we get the same numbers. All right, and you tell me which you like better. Okay, would you rather do it this way or would you rather complete the square? So let me just write it again. -2x plus 1. All right, what are we going to do? Before we complete the square, I like this to be a +1 out in front, so guess what I'm going to do? I'm going to factor out a negative. All right, so what's this going to be? X squared plus 2x, what? -1, right? Just taking a negative out of everything. So keep the negative there. What do we get? X squared plus 2x plus, I'm going to complete the square, do that. What do I, what did I do before? Yeah, let's put the +1 over here. Actually, yeah, that's what I did. I should have done this. Yeah, that's what I did earlier. So let's do it that way. Okay, it makes a little more sense that way. Okay, so we take it out of. Yes, because see, that's -x squared, that's -2x, and that's a +1. Okay, we're good. Let me finish this real quick. Okay, take half of this, which is 1, square it, it gives you what? A 1. But this is really a what? It's not a +1. What is it? It's a -1. So what do I do here? I add a, whoops, almost got ahead of myself. I add a 1 right there. Okay. Again, what do? Put a negative out in front. What's this going to be? It's going to be a perfect square, isn't it? That's what? X plus 1. What's that? +2. Check it out. Isn't that the same thing? Well, let's just look at our vertex. What's our vertex? I'll just put V for vertex. Not 1. It's -1. Because remember, it's X minus a minus H. Minus a -1. So look at that. We got the same exact vertex, didn't we? Would you rather do all this stuff or You got to remember this, though, this part right here, that h and k. Or would you rather just take my formula and just put the a, b, and c into those things and work it out? I think this way right here might be a little bit easier. But can you do it the other way? Absolutely. And you still get the same thing, don't you? Make sense? All right. And it kind of, yeah. See? Like this? I don't think they make you write it like on that example 6. Well, on example 6, they just ask you to find the vertex, the axis of symmetry, and if it's maximum or minimum. That's all they ask. So they don't ask you to write it like this. But if they do ask you to write it like this, which numbers, what is the, I don't have it in front of me. What's it say? Okay, what's the instructions say? Okay, so this would be vertex form right here, all right? So this is what they give you. So I would say writing it, completing the square thing will give you this. And I think that's what they want as vertex form. If they only ask for the vertex and the axis of symmetry and the maximum or minimum, you don't have to go through all that. Okay? You could just do it this way, and you should be able to tell what the vertex is, what the maximum is, what the axis of symmetry is. Okay? But if they ask you to write it in the vertex form, yes, you will have to go through this and do that. Okay? So it all depends what they ask you to do. We good? All right. I didn't write down the problems. What are the problems? 13 to 33 odd. Anybody start on that yesterday? Okay, so just do what you didn't do yesterday. So it's 13 to 33 odds. So some of you got some of that finished. If not, you got all of that to do. Okay, it's just the odds. All right, so that makes it kind of nice. And there you go. How's that?